Good day everyone. In today's video, we are going to attempt to find the sum of three terms. This is the first term, the second term, and the third term. But before we jump into the problem, I want us to recall the definition of logarithm because that will help us to appreciate the property of a logarithm that we're going to use to solve this problem. Alright, let's begin by attempting to solve a question on exponential equation. Let's say we have 2 raised to power y is equals to 8 and we are to solve for y in this question. How do we go about this? All we need to do is just to write 8 in index form. That will be 2 raised to power 3 and we have 2 raised to power y here. The bases are the same, then we can equate the powers. So we'll solve for y is equals to 3. But what if we have a problem like 2 raised to power y is equals to 13? Now, it's pretty very hard, in fact impossible, to use the concept of exponents that we use in solving this first question to solve the second question. And that's where logarithm is going to be of great help. Instead of attempting to find the index form of 13 so as to get the value of y, what you need to do is to find the logarithm of 13. That is where logarithm comes into play. Logarithm of 13 to base 2, this base. The log of 13 to base 2 is going to give us the exponent that we are looking for, which is y. Y is the exponent that we are looking for. So then you put your y here. Good. So what's logarithm? The logarithm of a number to a particular base, let's say b, is equals to the exponent or the power to which that base must be raised to, which is b, so as to give us n, which is the number. Let's put it this way, y. So for the sake of convenience, you use an arrow to indicate this. That's okay. You have b raised to power what? B raised to power y is equals to what? N. That's the definition of logarithm. So we have established that if we have the log of a number n to base what? B to give you y. So this is the same thing as b raised to power y. Use that arrow for the sake of convenience. B raised to power y is equals to n. So let's take this as equation 1 and let's take this as equation 2. So here's the property of logarithm that we are going to use to solve this question. Let's rewrite equation 2 without the power. B is equals to n. And let's go back to equation 1. If you look at equation 1, we have log n base b is equals to y. We can rewrite it as y is equals to what? Log n base b. So therefore, this y here in equation 2, we can replace it with log n base b. So let me keep the property of the logarithm up here. We have a base and the base is raised to a power, and the power is actually the log of a number to the same base as b. Then what you're going to get is the number in that log. Now let the show begins. Let's find the addition of this first term, this is the second term, this is the third term. So we're going to take this one first, and that is a raised to power the log of 7 base 3, put it in bracket, raised to power 2. Yeah, of course, log 7 base 3 raised to power 2 means that you're having log 7 base 3 multiplied by log 7 base 3. So that's the implication of that statement. So here now, a raised to power log 7 base 3, let's put a bracket there, multiplied by log 7 base 3. For the sake of convenience, let's put a bracket here. Okay, good. And we have it here too. Good. Now take a look at the top of the screen. Now we are given that a raised to power log 7 base 3 is equals to what? 27. So I'm going to replace what I have in the blue bracket with what? 27. Then I still have my log 7 base 3. Okay, so it's becoming very interesting now. Now, we can write 27 in index form, and that is 3 raised to power 3. So we have 3 raised to power 3. Let's put this in parentheses, and we have log 7 base 3. Okay, so if you remember the rule of indices, a raised to power m brackets raised to power n, so that is equals to a raised to power m multiplied by n. So we are going to have 3, this power, this exponent 3 will multiply log 7 base 3. So we are going to have it as 3 log 7 base 3. Now let's recall another property of logarithm. If we have n log m base p, the n behind here will come up here to become the power of m, and you're going to have log m raised to power n base p. So the 3 here now will come up on 7, and you're going to have 3 raised to power log 7 base 3 raised to power 3. So this now becomes 3 raised to power log 7 raised to power 3 is actually 343 base 3. Now, if we consider the property that we discussed earlier at the beginning of this video up here, that's why I still put it up there. So when you have b raised to power log n base b, that's going to give you n. So 3 raised to power log 343 base 3. So this is going to give us 343. So the first term is 343. So let's keep the first term here. So let's proceed to consider the second term. So the second term is b raised to power log 11 base 7, everything in bracket, raised to power 2. Alright, so we split this one into 2 places. So then we have b raised to power log 11 base 7 multiplied by log 11 base 7. Okay, so we are going to put a big bracket here. Let's put a big bracket here. Good. Alright, good. Now let's go back to the question. In the question, we are given b raised to power log 11 base 7. We are told that that is equals to what? 49. So we're going to put 49 here now. So we have 49 raised to power what? Log 11 base 7. Good. We're progressing. So let's have our 49 index form. 49 index form, that is going to be what? 7 squared. 7 squared multiplied by what? Log 11 base 7. Okay, good. So let's have it as 7 raised to power 2 log 11 base 7. Okay, so recall that the power rule of logarithm, where you have n log a base b, and you're going to have log a raised to the power n base b. So this flips to the other side. So 2 will also come up here and become power. So you're now going to have 7 raised to power log 11 squared base 7. So this becomes, we have equal sign, then we're going to have 7 log, what is 11 squared? That is 121 base 7. So we'll go back to the property that we talked about at the beginning of the video. So 7 log 121 base 7 is actually equals to what? 121. So that's the value of the second term. So we're going to keep that one here, 121. Alright, for the third term, good. We're going to have c raised to power what? Log 25 base 11, everything what? Squared. Okay, so we are going to rewrite these 2 times log 25 base 11 multiplied by log 25 base 11. So we can put this in a big bracket. Good. Alright, so let's go back to the question again. We're told that c raised to power log 25 base 11, that is going to give us root of 11. So we have the square root, so we replace everything in that parenthesis with square root of 11. Square root of 11, then we're going to have log 25 base 11. Okay, now mind you, square root of 11 is the same thing as 11 raised to power half. So we have 11 raised to power half multiplied by what? Log 25 base 11. Good. So we flip half to become the power of 25. So we're going to have 11 raised to power log 25 raised to power half, and we have base 11 here. 25 raised to power half is the same thing as the square root of 25. So we have 11 log square root of 25 base 11. So the square root of 25 is actually 5. So we have 11 log 5 base 11. So using the property of logarithm that we have up there, 11 log 5 base 11, that is going to give us 5. So this is the value of what? The third term. So the addition of these 3, 4, 3 plus 1, 2, 1 plus 5, that is going to give us our final answer. And this is 9. 4 plus 2, 6, and 3 plus 1, 4. So our final answer is 469. Thank you so much for watching.